Hello, we are starting Unit 7, where we're going to be looking at circles. So 7.1, the lesson objectives, I can identify the parts of a circle, find the circumference and area of a circle. Alright, so first let's talk about what a circle is. A circle is a 2D shape made by drawing a curve that is always the same distance from the center. So let's just recap. That is a curve, always the same distance from the center. And we name this with a circle and then dot in the middle, circle J. All right, and then the radius is the distance from the center to the circumference of a circle. So distance from the center to the circle. So an example of that would be like from J to F, and you're going to label that as a segment. So JF is the radius. You could also put JG or JD. All right, now let's talk about a chord. A chord is a line segment connecting 2 points on a circle. So it's a segment connecting 2 points on a circle. All right, so a chord would be like AC. So it connects points AC. Also note that G to D are connected. So that would also be considered a chord. Would XM be a chord? No, because M does not lie on the circle. Now, diameter is a special type of chord. So diameter is a chord passing through the center. So a chord passing through the center. So that is also JD. So note that GD is a chord, but it's a special type of chord because it goes through point J here. All right, so identify each part of the circle below. This would be circle P. The radius could be PM. Could also be PN or PL. The diameter would be LN. And a chord could be like MN. Also note that our diameter LN could serve as our chord. All right, let's talk about if QV is 4, what is the diameter of circle Q? So QV is our radius of 4, but note that QT and QU are also both radii. So those are both also 4, which means that the diameter of circle Q is 8. All right, if TU is 14 feet, so if this whole distance right here is 14 feet, we want to know what the radius of circle Q is. That's right, it would be 7 feet. So just note that the radius is half of the diameter, or the diameter is twice the radius. All right, we're going to talk about congruent circles. So radii are congruent in congruent circles. So this is saying that GH is the same distance as JK, that those are the same radii. All right, and then concentric circles are coplanar circles that have the same center. So note here that they are both centered at A, but the distance from A to B is shorter than A to C. And so some real world examples of both of these. Congruent circles could be like car tires. If your car tires are not the same distance around or don't have the same radius, then your car is going to be a little off and bouncy. Concentric circles, think of a dartboard or a target board where you have circles going in to the center for the bullseye. That would be a good example of concentric circles. All right, let's talk about circumference. So circumference equals pi d or 2 pi r. You guys have hopefully seen this before. And then area equals pi r squared. So we're going to use these in the future here. All right, so find the circumference of a circle with a radius of 2.5 centimeters. So we just said that circumference equals 2 pi r. Plugging in my 2.5 for my r, I get 2 pi times 2.5. 2 times 2.5 gives me 5 pi for my exact. And then rounding and typing that into my calculator using the pi button, I get about 15.7. All right, again, let's find the circumference of a circle with diameter of 16 feet. So my circumference equals pi d. So I get 16 pi for my exact. Plugging that in, I get 50.27. And note that these are feet. So circumference is not squared or anything, it's just the label because it's a distance. All right, so these are two problems. Let's first look on the left here. Find the radius if the circumference of the circle is 36 pi. So we said our circumference equals pi r, or sorry, 2 pi r, because we're looking for our radius. So we're going to use 2 pi r. We said the circumference of the circle is 36 pi. So I can set 36 pi equal to my 2 pi r, divide by 2 pi on both sides to solve for my r, and I get 18 to be my radius. All right, on my right here, my diameter is 10, so my circumference is 10 pi, or you can write that out to be about 31.4 millimeters for my circumference. All right, let's find the area if the diameter is 10 centimeters. So my area here, remember, is pi r squared. If my diameter is 10, my r is 5. So plugging that in, I get pi 5 squared. So I get my area to be 25 pi centimeters squared. So note here again, area, we're squaring our units. So this is approximately 78.54 centimeters squared. And note if you use the pi button or the 3.14, they'll be just a little bit off. All right, let's find the area of the radius if the radius is 2 square root of 2 yards. So area we said equals pi r squared. Writing this out, we get pi 2 square root of 2 squared. Squaring both of these, I get 2 squared to be 4. So I get 2 squared to be 4, and square root of 2 squared to be 2. So I get 8 pi, and that's approximately 25.13 yards squared. All right, let's find the radius if the area is 25 pi meters squared. So if my area is 25 pi, my equation for that is pi r squared. So I'm going to divide by pi to solve for r squared. That's going to cancel on both sides, so I get 25 to be my r squared. Taking the square root of both sides, I get my r to be 5 meters. And notice here, since I took the square root, my labels are just, or my units are just meters. All right, here, my diameter is 14, so that means my radius is 7. So I get an area of pi r squared. So I get 7 squared to be 49 pi, which I can approximate to be 153.94 inches squared. All right, let's talk about an inscribe. So polygons are inscribed in a circle if all of its vertices lie on the circle. So just off to the right here, you can see that L, M, N, and P all lie on the circle. And then circumscribed is circles are circumscribed about the polygon if it contains all the vertices of the polygon. So that would be saying that the circle is inside of the polygon as such. So circumscribed is when the circle's on the inside, inscribed is when the circle's on the outside. Alright, a square with side length of 9 inches is inscribed in a circle J. Find the exact circumference of circle J. So note here we have a square. So all of these are 9 inches. We want to know what this distance right here across the middle is. Thinking back to last unit, we can see that this is a 45, 45, 90 triangle. So we can say that this is 9 square root 2. So we want to find the exact circumference. So circumference, remember, is pi d. And so if my diameter is 9 square root of 2, I get 9 square root 2 times pi inches. Last one here. We want to find the exact circumference of a circle with a circumscribed square with sides 10 feet long. We're looking for the exact again. So here my diameter is 10, so I get 10 pi feet for my exact circumference. All right, good luck.